Welcome to my video. In this video we're going to do a comparison of the searching algorithms, binary search and linear search. This is for AQA's GCSE in computer science. Here I have placed an example of both a linear search and a binary search. For these I have used the same list for both. If we take a look at the linear search, we notice that it has taken 1, 2, 3, 4, 5, 6, 7 comparisons to identify whether the number we were looking for, 67, was in the list. If we look at the binary search, we'll notice that it's taken 1, 2, 3, 4 comparisons to identify whether or not the number 67 was in the list. On this small list, the difference is very small, and there would be minor difference in the running time. Let's take a look at the advantages and disadvantages of both. The linear search does not require the dataset to be in order. What this means is, here, this dataset is in order because it runs from 11 to 101. However, if these were all jumbled up and just in any random order, the linear search would still work, but the binary would not. The linear search also would work on any type of storage device. The linear search is quite efficient for small datasets, and this here is an example of that. However, it's very inefficient for large data sets. The binary search, however, requires the data to be in order. So in this example here, the data is in order. It runs from 11 to 101. If it was jumbled up, the binary search would fail to work. This is a disadvantage of the binary search. However, the binary search is more efficient and quicker on larger lists. If we take a look at this again, here, this one took 7, this one took 4 checks. The larger the list, the larger this gap would get. This is why the binary search is more efficient. What I've done now is I've taken some exam questions. What I would like to do is run through these with you and show you how to maximise your marks. This question states, why would the binary search algorithm not work when the array contains 6, 4, 15, 873, 645 and 42. Feel free to pause the video at this point and have a go yourself. So, what you should have come up with here is that the array is unsorted, or potentially the array is not in order. Now this here, those are the same answers, just written slightly differently. You'll notice that this is a 1 mark answer. So to get the 1 mark I've had to give 1 point. Now I've given 2 examples, so you could have wrote either of those and gained the mark. Moving forward, a programmer wants to implement a searching algorithm to be used with a small array. The figure below shows an example array, 5, 7, 9, 13, 16, 17 and 22. Using the figure above, explain how a linear search would search for the integer 16. So this is a 4 mark question, and what you're going to be expected to do is write down each step that it would go through in a linear search to find the answer. Now quite often I see a lot of students write, it starts at the beginning and works through and gets to the end. That would not give enough detail because you've literally given one very vague point. So what you need to do is break it down and literally talk to them or give the answer in a step-by-step approach. So this is how I would attack it. Again, feel free to pause, have a go at this question and then check your answer with mine. The first thing it would do is, it would begin at the element 5, okay? Or you could say at the index 0, okay? So it would start here. It would then check if that is equal to the value that we're looking for, 16. So is 5 equal to 16? Okay, if it was, it would stop, but obviously it's not. So the next thing it would do is, it would iterate over each element within the list, sequentially. Sequentially just means one after the other. If the element in the array does not match the value being searched for, the array continues to iterate, continues to go through the loop, basically, until it's visited every item. The search returns true when the element matches the item that we're looking for. So at this point here, it would become true. Now you'll notice it was 4 marks, but I've actually got 1, 2, 3, 4, 5 points. However, 2 of the points here are actually very similar, okay? This one's actually probably a better one than that one there, okay? So just make sure you put enough detail in your answer. Finally, the programmer knows that a binary search algorithm is more efficient than a linear search algorithm. Explain why efficiency of these 2 algorithms is not important when the algorithm is implemented on the above figure. So it's talking about this one here, 4, 6, 8, 12, 15, 16, 21. Now it's in order, so the binary search would work. they're expecting 2 points. Now bear in mind, I said earlier that, in fact I'm not going to say it, I'm going to give you a chance to pause now and then we'll go through the answer. No, it's a pause, I'm about to go through the answers. Right then. So I said earlier that a linear search is efficient on small lists. Okay, so your answer needs to cover that, and you need to do that in 2 points. And this is how you could have done it. The array is small. The runtime on both algorithms would be very similar. The difference in runtime would be negatable. This means that there would be very, very little difference, or a very unnoticeable difference. This is because there's not a lot in there, so it wouldn't take long to get through the list. Okay? Thank you for watching. I hope you enjoyed this video. If you have any questions, please feel free to get in contact.